Hey, what's up, guys? Welcome back. I want to take a little time to go through the free fall worksheet. So I'm making an answer key here and trying to give you guys some explanation if you're struggling with this stuff based on what we talked about in class. So a couple things that you want to take kind of mental note of is, it's okay if you made mistakes when you did it, and now you know that you did it incorrectly. So just be sure that you're kind of looking at yours while watching this video, so that you can look at what you did and what versus what you should have done, so that going forward you can do these things correctly. And what I did, which is maybe a good idea for some of you to do in the future, I looked through the notes from the other day before you did the worksheet, and I just copied and pasted some of the equations there to the top of the sheet so that I would have those handy for while we're working on these. So when I look at the first one here, assume you drop a golf ball off the roof of the Empire State Building. How much time will it take the object to fall 45 meters? So most common wrong answer, kids did 45 divided by 10 and got 4.5 seconds. So there's no formula up there like this. But if it says how much time, so I know I'm looking for time, and I've got these two equations. It gives me a distance, so that means I'm going to use this equation right here. So I'm going to copy this one down, paste it in, so I know I'm using that. And then that's going to equal, and I'm just going to type square root of this so I don't have to go through and find that symbol. But 2 times the distance, so 2 times 45 divided by acceleration, which is 10. So I find the square root of 2 times 45 is 90, divided by 10 is 9. So the square root of 3, or excuse me, square root of 9, which ideally you know in your head is 3. And the unit for that is seconds because it's asking for time. And then how fast we'll be moving at the end of 45 meters. So now I've got a picture in my head, something's fallen down 45 meters. It took 3 seconds. I want to know how fast. So how fast, I've got this formula right here. So I can copy that one, paste that here. Oops. And then I know that acceleration is 10 for 3 seconds. So then I get 30 meters per second. So those ones, if you figure out which formula, then they become pretty easy to use. Rate of acceleration of a freely falling penny is 10 meters per second squared. How long should it take the penny to reach the ground if it's dropped from a 150-meter cliff? So one thing that was curious to me when I was looking through these is some people did this right, and then for this one they did 150 divided by 10, which is they got 15 seconds, which is wrong. And it's again, they're just making up a formula. So this is really the same thing that you did right here with 1A. So we just have to use that formula again and plug this in. And let's see here. So then that becomes square root of, and 2d, so 2 times 150, so that's 300 divided by 10 is the acceleration. And then if that 300 over 10 is 30, so I need the square root of 30. So 30 square root 5.48. And that, again, that unit is seconds. So, once you knew to use the right formula here, then I think that one's okay. And here, Sylvia falls off the 10-meter high platform at the pool. Ian is standing at the 3-meter high springboard as she goes by. So here's Ian, here's Sylvia above him. So first question says, from his perspective, what direction does she seem to move? So he looks up and she's moving down. And then from her perspective, she's going this way. What way does he seem to move? So it would look like he's coming up. She's moving down, but to her, it looks like he's coming up. So those perspective ones, you guys seem to do a good job of those. So I was glad. And But simple as that is how I would want you to answer those. And then it says, what speed will she have as she passes the 3-meter high position? So I give you a hint to find the time first and then the instantaneous velocity. And really, this is the exact same thing that you did in 1A and B. You found the time and then you found how fast. And so she passes the 3-meter high. So she went from 10, fell down to 3. So one thing that loused people up here was that they did the distance wrong there. So the distance that she's traveled in falling there is really 7 meters, because she started at 10 and was passing position of 3. So she fell 7 meters there. So that would be the square root of 2 times 7 divided by 10. And so that equals, let's see, square root of 1.4. 1.18. So that equals 1.18 seconds is the time it took. And then we want to know how fast she's going. So what speed? So again, we use this formula up here to know her final velocity, because her initial velocity was 0. So put this in, and I take acceleration of 10 times 1.18, and that equals 11.8 meters per second. So really, I've done, in finding the time, I've now done it the same thing 3 times, and finding the speed of a falling object, I've done the same thing twice. So this one, we had some struggle with this. So let's see, how much time for the ball to reach its highest point? So it's thrown upward at 25 meters per second. And so its velocity is going to change by 10 each second. That's because of acceleration due to gravity. So after 1 second, it's going 15, and then after 2 seconds, it's going 5, and then it's going to take another half second for it to do that. So conceptually, you want to think about, oh, if it started at 25, it's going to take 2.5 seconds to reach the top. If it started at 30, it would take 3 seconds. If it started at 50, it would take 5 seconds. And really what you're doing there is taking the initial velocity, or the change in velocity, divided by acceleration. So if you need a formula for this, it looks like this: time equals change in velocity divided by acceleration, which is we've seen that before. I don't think about this formula when I do this one in my head, but you may need to or want to if you're doing it that way. And then here it says, how much total time will it take the ball to return to its original position? So if it takes 2.5 seconds to go up, it's going to take 2.5 seconds to come down. So I just double that time right there, and that gives me 5 seconds. How fast will it be moving when it returns to its original position? So it had gone up and slowed down, speed is 0 at the top, then it falls down for 2.5 seconds, gaining velocity or speed as it's falling. So it's going to be going 25 meters per second downward now when it comes back to its original position. So if you remember, things we talked about in class was up equals down. Those are the same things, just reverse direction. So if I throw it up at 25, I'm going to catch it at 25. Now for D, how much total vertical distance? So this was a little tricky, and here's where what you've got to do is look at this. So we want to know distance, and I have the formula up at the top for 1/2 AT squared, and I'm going to use that. The mistake that some of you did, which is real common, is that you used 5 seconds. And we can't do that because it would assume that like it reaches a velocity of 50 meters per second at the end. And so it doesn't do that because it's slowing down and then speeding up. If you use 5 seconds, you assume that it speeds up the whole time. So what you've got to do for this is do half times 10 of acceleration times, we just use the time to go one direction. Doesn't matter if you use the time to go up or time to go down because they're the same. 2.5, and instead of squaring it, I'm just typing times 2.5. So now when we get this answer, so I think it's 31.25, or if I remember correctly, I hope so, because I'm making an answer key. So this is now the distance just to go one way. So what we then do is multiply that by 2, and we get 62.5 meters. So that's how you find the total vertical distance. Overall displacement, this is really more of the definition of, do you remember what displacement is, which displacement direction matters. So if I went up 31.25, let's call that positive, and then down 31.25, so we call that negative, I got a positive number and a negative number that are equal, so my overall displacement is 0 meters. Another way to think about that is the ball's right back where it started, so its overall position change is 0. Now here we toss the ball straight up, catch it when it comes down. So you're doing this today for your lab or tomorrow, but what happens to the speed of the ball as it goes up? We know that it decreases. And I think everybody knows that the ball slows down on the way up. And on the way down, it increases. So those are simple, but I want you to always remind yourself of those when you're thinking about what you're doing. And what causes the ball's speed to change like this? Acceleration due to gravity. So most of you guys got those three, no problem. Then during its flight, what's true about the distance the ball covers each second on the way up? So some of you, I think, just didn't read this correctly. So we're just talking on the way up, and the ball is going to slow down, so it's going to cover a big distance relatively at the beginning, and then that distance gets smaller and smaller and smaller as it slows down. So it covers less distance each second as it goes up. So, and that's because it's slowing down. Then here the ball's speed at the top of its flight, I think everybody got that it was 0 meters per second. However, its acceleration, a lot of kids said that was 0 as well, and acceleration is still going to be 10 meters per second per second. So the acceleration is constant, so that anytime something's in the air, it's accelerating 10 meters per second squared downward. And it doesn't really, well, I won't say it doesn't matter what's happening to it, because if a bird grabbed it, it wouldn't be doing that. But if it's in free fall, its acceleration is 10 meters per second squared. So last set of questions here. I got a ball that's in the air for 4 seconds. So if it's in the air for 4, that means it took 2 seconds to go up. If it took 2 seconds to go up, so its initial velocity has to then be 20 meters per second. So if I throw a ball up at 20 meters per second, it's going to take 2 seconds to reach the top. If I threw it up at 10 seconds, or 10 meters per second, 1 second to reach the top. If I threw it up at 100 meters per second, then it would take 10 seconds. So some people put initial velocity of 0, which then the ball wouldn't go anywhere. Definitely not up, it would just probably start falling down. Velocity at the top, 0. So the average of 20 and 0 is 10 meters per second. Now here I had you calculate distance using the average speed. So distance is average speed times time. So that's average speed of 10 for 2 seconds, and that equals 20 meters per second. So I just use that and that to get that answer. And then here I had to use the distance formula, 1/2 acceleration times time squared. So that'd be half of 10. The time to go up is 2, so half of 10 times 2 squared. So half of 10 is 5 times 2 squared, which is 4. So this distance is also 20 meters. So I wanted you to realize in doing this that these answers, whoops, I had a wrong unit there, that these answers are the same. So I got about 30 seconds here. I'm going to just skip to this one before this video runs out. But this helps you understand the difference between velocity and acceleration. So here, the acceleration of both of these is the same, 10 meters per second squared. And so it doesn't matter that one has an initial velocity. That's totally independent and separate from its acceleration. So the acceleration of both of these is the same.